Hello and welcome. I am Piers and Dan, CEO of RDX Works. I'm here with founder Dan Hughes, and today we're going to be talking about questions that the community has been asking us. It's been a couple of weeks since our last AMA, so we've had some great questions. We're going to be going through them in reverse chronological order, which is the order that they are presented to us in. And so we'll be just going down through that. So first of all, we have a question by Cyprian on Telegram, and he's actually asked 6 questions, 4 of which have actually been answered previously in previous AMAs. So please do go back and have a look. I think in all of our AMAs, there's a time stamping in YouTube as to what questions were answered on the way through. So please do go back and look through our AMAs. So questions 3, 4, 5 and 6 have all been answered before, but 1 and 2 we will deal with now. So what exactly is the difference between the block notion that is used in most crypto technologies and the states in Radix?
Yes. This question comes up, well, not question, a conversation around and
Right.
people who are new, like, why is Radix on a blockchain? It's like,
Right.
What is it then? Is it a DAG? Is it something else? So most of when you get into consensus, like crypto doesn't really use the mainstream terms, right? So if you look at classical consensus mechanisms like PBFT and stuff, they talk about proposals as the thing that is presented to the network as a next thing to do, right? Or a batch of things to do. It's not necessarily a block. So when we're thinking about moving consensus forward, if you've read the Cerberus paper, you've probably come across this term of proposal many times. And so a proposal is essentially what somebody in the network is proposing the network does next. Now that can be a single transaction, it can be a few transactions, it can be some related transactions that form a bigger set of actions that have to happen consecutively, or it can just be a batch of things, right? Whatever it is. So we don't use the term block because even though in some cases that might be a comparative term, if it's just a batch of stuff that's been stuck in a proposal to do, it's not always accurate when you're looking at, okay, what is the Radix network doing or going to be doing, right? A proposal can just be one thing, or it can be related things or whatever. So we don't use the term block because it doesn't capture what could actually be happening. So we use the term proposal. So when you're looking at a local consensus instance, right? So forget Cerberus right now. We've just got a set of validators, and they're all looking at what they want to be, what's going to happen next. You'll have proposals that are being generated either by a leader or in Cassandra's case, various entities. And those proposals then get voted upon, and those proposals form a proposal chain. So it's a little bit like a blockchain, but the proposal it is more flexible, right? So you have this kind of proposal chain. So in your local consent, there might be orphaned things that didn't get selected or things that failed to branch off from that little bit. But you essentially have this chain of proposals. So from that point of view, you could say, oh, well, it's a blockchain then. It's like, kind of, but not, especially when you bring Cerberus in, right? So you bring Cerberus in, and depending on which implementation of Cerberus you've used, the proposal chain potentially no longer becomes a chain, depending on how your implementation of emergent Cerberus is working. But even if you go for a very basic Cerberus implementation and you don't use the emergent stuff, you still have a proposal chain underneath in your local consensus, but you have multiple validators in different shard groups that are processing stuff that are within that proposal chain, right? So you actually end up with kind of 2 layers. You end up with, like, potentially, in the most simplest case, you end up with a proposal chain in the local consensuses. But then at the Cerberus layer, where you're having to do cross-shard stuff, you actually end up with a DAG, right? Because you've got this directed acyclic graph that's going off to all these different shards. And then when things happen on those shards, that gets extended again. So underneath, you've got all these potential proposal chains or things that look close to chains. But then you have an overlay, which Cerberus has on top, which looks like a DAG, right? So that's why we don't call it a blockchain, because it's not very accurate, right? There are bits that look like a blockchain and there are bits that look nothing like a blockchain. So depending
It's a
on
block DAG.
It's a block DAG. I mean, it's not really even a block DAG because,
no, it's not. Because like a DAG also describes how it reaches consensus, and that's not, as in like part of the way that a DAG works is linked to how consensus in a DAG works, and we don't.
Well, I mean, this is the thing,
well.
right? It's like
Right.
People have been touting DAGs as a consensus mechanism, but a DAG is actually just a data structure, right?
Right.
And like blockchain, a Bitcoin is a DAG. It's just that it's only got one branch, right?
Right.
It's still a directed acyclic graph. The acyclic thing means it doesn't join back to itself. It just keeps moving forward, right? It's open-ended. Right. And DAGs have been around since forever, right? Way before crypto and Nakamoto and everything. Right. Yeah. Right. It's just a means of describing a particular topology of how data is constructed, right? And there are some interesting things you can do, but it doesn't always relate to consensus.
Right.
So you have like there's just these multiple layers of data structures, and your proposal chain will have references to things in the Cerberus DAG, if you like, and the Cerberus DAG will have references back to all the different proposal chains. So if you look at it from a kind of bird's eye view, it doesn't really look like anything. It doesn't look like a blockchain, and doesn't look like a typical crypto DAG either. Right. It's kind of a mash between of the two, and you have all these kind of links and references.
Right.
Across all
and it's not as unstructured as a typical DAG implementation is either, right?
It's actually probably it's more unstructured because you have multiple DAGs that sit on top of each other as well, right?
Right, but as in like the where the next branch sits is deterministic rather than it being like it can just arbitrarily be.
Sure, yeah. So from the point of view of me spending some funds, then I will always be building on the end of the branch of any particular DAG where my funds currently sit, right? That particular UTXO. But I might be building on multiple tips, to use IOTA terminology, multiple tips of the DAG if I've got multiple UTXOs, right?
Right.
But then I may also have multiple DAGs existing in the Cerberus layer, because there'll be one DAG that's for XRD, there'll be another DAG that's for Piers token, because when you create your Piers token, that's going to instantiate a new DAG that deals with the UTXOs of Piers tokens, right? So you end up with multiple DAGs stacked on top of each other that also have references to each other as well. So even though from the Cerberus paper it's very simple, you've got proposals that build on each other, and you've got these emergent references out into across these other shards. When you take a step back and think about, okay, how does that look from a data structure point of view, it becomes very complicated. So just saying it looks like a blockchain, so it's a blockchain, is not actually genuine,
right? And it doesn't bear any resemblance to IPFS, but in some ways the way that the data structuring works, as in like the way that where a piece of data lives as a result of the transaction, contents of the transaction itself. There's also elements of that as well to help with the addressing of transactions from the point of view of the.
It's just a big, huge reference graph, basically, and you've just got multiple layers to this graph. So if you're up here looking down, you can always find your way to some root point, right? So you can go through all these different DAG layers, and you can follow the references between these different levels of DAG, and then eventually you'll get down to the proposals layer, which is what the validators have local consensus doing. And depending on if it's an emergent Cerberus or linear Cerberus, depends on how many proposal chains you're looking at. And it's it's a different thing, right?
We need a name for it.
Yeah.
The block graph DAG.
So yeah, I mean, people will point at bits of it in the future and be like, "Oh, you said it wasn't a blockchain; it's a blockchain."
That's a blockchain.
Yeah, but
right.
you're just looking at that bit.
Right.
Zoom out and tell me if it looks like a blockchain.
Right. It's sort of like it ends up looking like this spider web.
It just looks like a soup of stuff, right? If you're just looking at it, it's just a mash of lines going from one place to another. And it's like, is there any structure in there?
But the reason I reference IPFS is because there is this sort of like very thoughtful way in which data is actually addressed. So even if you just look at it as a whole, you'll go, well, that's a mess. But if you actually address it from the point of view of, I want this transactional data, I want to know where this, state
clear
lives,
roots across
that's like
graph.
instance.
Yeah. Same here. Same.
Yeah. Okay. 2. Cerberus seems to be referred to as an additional layer over the Radix engine. Does this mean that the emergent Cerberus logic will run on a different node that braids the QC results obtained from the validator node leaders of each shard?
Yeah. So Cerberus actually lives underneath the Radix engine, right? And from a stack point of view, Cerberus and all the local consensus instances don't care about the Radix engine. And the Radix engine doesn't particularly care what consensus looks like, right? But you do need to have a layer in the middle so that the Radix engine can push and pull data to and from the consensus layer to say, hey, process this, right? Let me know the results. Or I want to do this state transition, but is it valid? And was it correctly processed before, right? Give me the proof of that, or whatever the Radix engine needs. But they're serving two different purposes, and all they need to be able to do is talk to each other. So you could have a blockchain underneath the Radix engine, and it wouldn't matter. Or you could have, you could have a DAG, or you could have what the block DAG thing that we've got, right? Doesn't actually matter.
Block DAG graph.
Yeah, that thing, right? So you've got local consensus, then you've got Cerberus, then you've got Scripter and the Radix engine that sits above that, and there's communication bridges between those different pieces of the stack, so they can all talk to each other, but they're all just doing their own thing, right? So from an emergent Cerberus point of view, if you're thinking strictly about the Cerberus paper, you have this particular transaction that touches multiple sets of validators, right? Multiple shard groups. And so when that emergent Cerberus comes to life is when this transaction has been sent and everybody in the network knows which shards that transaction touches, so they know which validators need to be part of this emergent Cerberus instance, right? And then that emergent Cerberus instance emerges, and all the validators that need to be part of the validator set for that instance all know that they should be there, right? Then there is essentially a leader selection, so a seeded deterministic mechanism of saying, okay, which of these validators that are in this Cerberus instance is the leader that's going to collect the votes and form the QC for all the things that are going to happen, and then that Cerberus instance that's emergent then spins up its own instance of consensus, which in this case, keeping it simple, would be hot stuff, right? Or it could be PBFT or something. But let's stick with hot stuff because that's what we're using in Olympia. Hot stuff would do its thing. All the validators in that emergent Cerberus instance would send their votes to the leader. They would execute the transaction, whatever. And then when it's finished, the quorum certificate that was produced by by that emergent instance then gets recorded in all of the local instances of the validators that took part. So that Cerberus instance then it disappears, it's finished, but you've got a record that it was spawned, something was executed, a result was met, agree, disagree, whatever the output was, and then the output of that emergent instance is then recorded in all the validators locally, that executed it. So that if a new validator comes along that joins that group, they can sync up, they can replay, they can verify that everything happened correctly, because the quorum certificate that it will get given tells that newly joined validator who has taken part, which you can verify because it's all deterministic, right? Who took part, who voted, what was the input, what was the output, and it can verify all that stuff. So I think that answers the question, right? So
the answer is yes, apart from
only one
services
leader.
below,
An
not
emergent
above the
Cerberus.
Radix engine.
An emergent Cerberus, as per the papers, there's only one leader. So it doesn't matter if all the validators that were part of that emergent Cerberus instance were leaders somewhere else. Doesn't necessarily mean they're going to be leaders of this one, right?
Right. Cool. And as I said before, the other 4 questions we have answered separately in previous AMA, so please do go back through and do that. Thank you for your question, Cyprian. Next question by Yo. Any ideas on if and how we would have to pick validators? Say 5 years in the future, where there are tens of thousands of validators, no one's going to look properly for validators. Then if they sometimes already resort to the top easy 10, right now already with 100, a lot of people just go, oh, I'll just do the top 10, which you shouldn't do. That's bad. That's bad behavior.
Yeah.
Bad behavior. Don't do that. Follow the rule of 5 and 5. So 5 validators, your stake spread between 5 validators with no more than 5% on any of the validators, and the validator has no more 5 than 5% of the total stake of the network, and be the champion of new validators. That's a great question. What do you think? What's your take on this?
Yeah, I mean, it's an interesting question, right? Because potentially in 5 years' time, Xi'an's out. There's $400 trillion locked on the Radix network, and there's going to be, potentially thousands, if not tens of thousands of people running validators, right? Various specifications and et cetera, et cetera. So how do you actually pick where your stake is going to go? Or does the network pick for you? Do you just say, hey, I want to stake this, right? Go and spread it where it needs to be. Which may not be a bad solution, because then you could guarantee that stake is uniformly, at least delegated stake is uniformly distributed, right?
Right.
But
then you sort of have attack vectors that play to that idea.
But then, right. Well, where is the gameability surface there? Where is the attack surface there? No one's actually going to go through 10,000 validators and put their stake there, right? It's gonna have to have some form of automation. It's gonna have to.
I think that these kind of questions are really interesting, because often they focus on the technical side of things, from a theoretical point of view. Given no extra layers of abstraction in the network, no extra levels of user interface or services or search criteria or any layers that we know always happens as services mature and as ecosystems and economies built out around things. We know look at what you can buy an app. You can download an app on your phone to do now. You can download an app to do almost anything you can possibly imagine in your life, because there's enough business there to service almost any niche of wants and desires that humans have, because the market's so large. And so in 5 years' time, if we have huge amounts of value on the Radix network and Xi'an is there is going to be a services economy that builds up around that. And so I can't actually predict what necessarily is going to happen, but there's this duality of people that want the network to be secure, and people that want to have an easy life. And I think that there are going to be services that cover off both. Now, that obviously there's centralization risk in things like search functionality that give you recommendations. We recommend you stake to these nodes because we've, done the due diligence on the backgrounds of the team and they're identified, and, that we've seen what their service level has been for the last 3 months and they haven't missed any proposals, and they've done all the hard work of going, this is what you should do as an individual, but we've done that for you. And now here's a service that just recommends you 5 nodes. And I want to stake. Here's 5 nodes. Go ahead and stake, right? It's one of those, for me, these questions often are a little existential. It's like, let's see when we get there. Mm-hmm. Because when we get there, the network's going to look very different from what it does now. The community will look very different from what it is now. And like sometimes those questions, I get like this existential angst, and then I go, yeah, don't worry about it. Like it's not a now problem. It's a later problem. And like that, and the solutions will emerge. Like either they'll be technical or they'll be social or there'll be a combination of the two. But like, the great thing about these communities is they tend to enforce behaviors that people understand overall help the network be successful. And that's sort of happened in the past, and I think it will continue to the future.
I think like one position that I'm coming from in terms of research I'm doing, right, is that a large aspect of it, it's not spawned by this particular kind of question, but it definitely has an influence on what this might look like, right? So, like ideally, you want as many people as possible to be running a validator, right? If your network is such that it can handle large amounts of validators, right? So, and let's just say, for argument's sake, that the upper bound on Xi'an, the total number of validators the network can support is unbounded, right? So you can put as many validators in there as you want. So then the question becomes, okay, so what's the friction that would mean that somebody would choose to delegate their stake rather than just running their own validator, right? So obviously the first one is the specification of the validator. Yeah. Right. If you need a validator that's got 1 million cores and gigamegs of memory and loads of hard drive space and fat bandwidth pipe, then that's going to raises the barrier to entry of running a validator, right? So you're going to have a lot more people doing delegated stake, which then leads you into that question, right? Mm-hmm. Then you have a higher risk of service providers popping up and possible centralization of some things and whatever. But if you can lower the barrier to entry of running a validator to such a degree where it's like it doesn't make sense not to, then that issue of choosing where to put your stake largely goes away, right? So in 5 years' time, TVs are going to have a few hundred gig of memory. They're going to have more powerful processors. Potentially, you could just run a fucking Xi'an validator on your TV, right? Smart TVs always connected to the internet, enough storage for them to jump around. And here's the other bit that plays into this. If your specification of validators is very low, then to meet the desired throughput that the network is demanding, you need more shard groups. Right. So instead of having few shard groups but very high performance validators, you have more shard groups with very low performance validators, which has an added benefit that if you have lots and lots of shard groups, then the amount of information that needs to be synced when you move a shard group is much reduced. And so a TV with 100 gig of storage might actually be a viable validator, right? Or a set-top box or your fucking fridge.
I think you're like, I think this is where you and I are like sort of slightly philosophically different. I think that you at base are a utopian. You're a cynic, but you're a utopian as well. You believe the world to be a negative place.
I'm a cynical, pessimistic.
You want the world to be a better place. I want the world to be better. Yes, exactly. Whereas I'm like, I think it's going to have like. What always happens is you have a professional layer comes up. If there's profit to be made, people will get, economies of scale and there will be a professional layer. That doesn't mean that we shouldn't strive to create a network that has the lowest possible barrier to entry to be a node right now.
Of course.
I mean,
there's a lot of benefits we got outside of that question for that as well.
Right. But I live in Switzerland and my internet in one of the wealthiest countries in the world still sucks. Like it goes down all of the time and stuff like that. And I'm like in a house with fiber to it and all that kind of stuff. And it's like, yeah, if my proposals, if I'm staking to a node and I get dinged every time I miss a proposal for my staking rewards, I would probably just go, well, I'll just go to a professional one, because at least they've got good internet connectivity, because it's not just the specification of the computer, it's also the specification of the
but if you have more validators, then the interval of you getting dinged is also going to be longer. So your unreliable internet connection isn't quite so critical, because, well, it's going to be 3 days until I'm up for a proposal again. So if Virgin Media haven't fixed by then, the validator is least of my worries. My children are going to be going crazy because they can't watch Peppa Pig and Ben and Holly. So,
but yeah, I'm definitely not disagreeing with the idea of striving for a reasonable specification. Within the reach of anyone to be able to run a node.
Yeah, which is why in like the Cassandra test, I'm always very happy when I forgot his name, when he comes around with his Pi 3, because it's like, right, how good has my coding been recently? Is this still going to work, or is it just going to explode? But I mean, it's like even if that isn't the solution to that question, right? The fact that you would be able to run it on your TV would definitely bring more people in. I can have a TV and it's just taking them in the background and I make some passive income. Cool.
It was actually, it's funnily enough, like complete side note, that was actually a really random conversation I had like in 2017, 2018, when I just started working full-time at Radix. I had this conversation with this guy who was working with a Chinese TV manufacturer, and he wanted to run a network of nodes on the installed base of the Chinese, and they put in this software that meant that they could actually just push the nodes to the TV without the consent of the people. And I was like, how many TVs? And he was like, oh, I don't know, like maybe 120 million. I was like, whoa. That's mad. So yeah.
And was it Bitfury that either wanted to or did put like micro Bitcoin miners in light bulbs or something? I'm sure somebody was doing that. I mean, yeah. If that's a thing, we can definitely get away with TVs with a Xi'an validator on it.
The new Apple display that goes with their sort of Mac Studio, the 5K one. That's got 64 gigabytes of memory. It's just turned out. It's got 60. I'm being a geek. I'm sorry. So next question. Question by Shang N Wu, also on Telegram. So no matter what, the solution is to keep gaining nodes, and the award for nodes should be enough to attract more people to be a node. That's a quote from us. So no matter what, the solution is to keep gaining nodes, and the award for nodes should be enough to attract more people to be a node. And the question is, so does the team figure out the sweet spot that can satisfy nodes and still have unlimited TPS and makes people who invest XRD get enough reward? So she doesn't mean invest, she means stake XRD. So those people who stake XRD, making sure they get enough rewards, given the fact that as you add more nodes, you sort of like your reward per unit staked theoretically goes down.
I mean, it's not our job to figure out the sweet spot. Right. So our job is to create a network that is as efficient as possible and is as secure as possible. And the whole kind of fee model is part of that as well. Right. So you get charged a fee so that you can't just dust the network with loads of transactions and stuff. And there's a processing cost, there's a compute cost, there's a storage cost associated with any transaction. And so the fee model has to account for those different costs in the network, right? But what the fee model doesn't do is go, well, okay, electricity has gone up in China, so the fee needs to go up, right? That's not our job to define a model that looks at that and varies the fee accordingly, so that validators and stakers keep a kind of linear progression of earnings over time. the fee model that we define is more from a technical point of view as opposed to an economic point of view, because you can't really control a market. Like, there's a free market here, right? And there's some equilibrium of that market whereby the amount of demand for XRD and throughput and all that kind of stuff will produce a certain amount of value for your validators. And if there's more validators in the network, there's more supply of validators than there is demand for those validators to process things and therefore earn, through staking and fees and all that kind of stuff, then some of those validators will turn off because it's not economically viable for them. And if there's not enough validators, then there's an opportunity for somebody to come in, run a validator, and take some profit, right? And the dynamics of that market, and any supply demand market, right? They're so fluid that to say that there's a sweet spot and to try and be able to point at that sweet spot all the time, depending on what that market is doing, it's naive really for us to ever think we'd be able to do that, because what's a sweet spot today isn't a sweet spot tomorrow, and it wasn't a sweet spot yesterday. What you're actually relying on here is the invisible Adam Smith hand to come in and make sure that market stays at an equilibrium, which it will, right? Unless there's some catastrophic event, the market, the validators, the earnings, the fees, the amount of load in the network, they will all come to a happy equilibrium, just as you see with Bitcoin mining, right? There's no sweet spot there. It just finds its happy balance because of costs, earnings. Cost isn't just money either. It's time, effort, and stuff as well, right? It's like the complete cost of running this thing. What is it? Time is valuable. Effort is valuable. So
yeah. There's a couple of things I'll say sort of as an addition here. The first is the fee model as it currently stands on Olympia will radically change when we get to Babylon.
It has to. It's a smart contract.
Smart contract. You have a bunch of extra complexity to do with the amount of processing time things take and all this kind of stuff. So like the fee model will be radically different, and there will be more elements of like economics in how the fee model is built. The other thing I'll say is that there is also always going to be a floor to the fee, and the floor is going to be very low, but the floor is there as a spam protection mechanism, because if you make transactions too cheap, you end up getting sort of a class of behavior that is just, you just don't want to encourage in a network. So there will you're not going to get fees going to zero, because they actually can't go to zero in the network, but you will have the ability for fees to adjust above that, and the ability for the number of nodes in the network to also adjust. So you will continually see this equilibrium effect over time.
I think the only thing that we really have to have a consideration for outside of the fee model, right? Because the fee model is really its purpose is, to help to secure the network, to help to prevent DDoS, to make sure that the costs and compute and stuff are used efficiently. But from an actual economic point of view, there are some things that we do need to consider. They're not particularly critical. They're more of a kind of an awareness, right? And that is that if the amount of demand for throughput in the network is very high, but the cost of maintaining and running a validator is also very high, then you have a potential where the demand for throughput is growing, but the available compute to deal with that throughput is not available because running a validator is too costly, right? And that's not a situation we want to get in, because we want it so that any amount of demand for throughput can come along. And there is always an opportunity for new actors to enter to help to supply that demand for throughput, right? Now, if that balance is off, then obviously demand will be there, throughput won't be there. So things like finality will go down, will increase. You'll get things that fail, Ethereum problems, basically, right? So from the economic perspective, that's probably the only thing that we have to actually consider.
Right. And actually, interestingly, that whole like spam prevention prevents another problem, which is like ledger bloat. Like while the sharding mechanism of Radix, this deterministically shard 2 to the power 256 shard, is incredibly efficient at dealing with like phenomenally large amounts of data, there is still this balancing act between sort of like essentially state management into the future plus throughput, and the cost of running the node is a combination of those two things, plus the syncing and bandwidth issues that comes in the background or around like with your churning of your validator sets, and they're continually having to resync. And the bigger the data is, so that's the other thing for the base fee, is making sure that you don't end up you're thinking about your long-term economic cost of running a validator, not just now can you process the throughput, but it's now can you process the throughput and store the state through time and sync that state through time, and has the fee model sort of taken all those things into effect as well.
In a perfect environment, you would have your throughput is growing, unless it's linear, right? You would have a linear throughput growth. So you would also have a linear amount of new validators joining, right? So your validator growth would be linear in the same way. But because your quantity of validators is increasing in the network, you would actually have more groups of validators, right, that are responsible for ever shrinking pieces of state. So in a perfect environment, what you would see is that the amount of data that each validator has to store stays flat. Because if you've got linear growth in throughput, linear growth in validators, linear growth in validator sets, then that equates to just a flat cost of storage, bandwidth use, etc., etc. Now, obviously, you wouldn't ever have a perfect situation like that. There'd be fluctuations and things, but that's ultimately the balance that you want to strike, at least over the macro term, right? You want to be able to look at it from a macro point of view and say, yeah, these are growing, that's staying fairly flat, we're all good.
Right. Yeah, I think these are one of these things that like is likely to be tweaked over time. Is sort of like the economics of the network will change as it gets larger and you get more actors and you get sort of more emergent behavior that comes out of it. And you, like a lot of these things, I always think about like nudging rather than controlling. It's like how do you create an environment where an equilibrium can occur and the equilibrium is at the right maxima? Because like in complex economic systems, you can have many local maximas if you design a system incorrectly, and you can end up in a weird state that you didn't actually want to be in. So it's about designing a system that has the right maxima, so it has the right bounds, but you're not saying I want that to be the point that the network's at. You just go, I want it to be able to emerge that is the Schelling point of the network for whatever it is that you're optimizing for.
Also, don't forget the validators themselves have a bit of a lever they can pull here as well, right? Because they're getting earnings,
right?
And they just simply don't sell. So if the balance is off, then they just accumulate earnings over time, and just in the same way that miners don't sell when the Bitcoin price is low, right? They withhold those earnings for until a time where their withholding of said earnings has influenced the market to such a degree where the price has moved to a point where it's then profitable for them to sell them. So you have a potential for the same kind of thing to happen here as well. I don't think it'd be as extreme because there's a lot more different moving parts here, but validators themselves, if that equilibrium point isn't met, they can exert a little bit of influence too. So the value of an XRD would increase if they were withholding large amounts of supply from circulating. So
yeah, which we actually see as a behavior in Bitcoin, as you say. Okay, so the next question is actually a question for me and Jeremy about metrics for events like South by Southwest. I'll hold that for our next roundtable, and we'll go on to the question by Yog1. Chen and Eden, young couple with a child, both successful careers, want to buy a house. They have some savings and want to use their job's wages as collateral for a mortgage. How will DeFi help them?
Go on then, Piers. You can take this one. You're a bit more clued in with mortgages and securitization of those things, etc., etc.
So the mortgage market's an interesting one because it's actually one of the more efficient financial markets in the world. This idea of securitizing mortgages. So like a bank goes out and lends to a couple with savings, and what they do is they assess that couple on their affordability and all this kind of stuff on the house, and make sure that the value of the house is approximately correct for what they're paying, and they've got enough deposit and all that kind of stuff. And then that involves a contract that basically says, if you don't pay, then we can come and collect, and in the extreme cases, repossess. When you touch the physical world, those things are really necessary. This idea of like enforcement of a debt or collection, and that is what makes it possible to do like under collateralized or non collateralized borrowing into the future. Now, the case of the house, it is actually a collateralized asset, and because it's a collateralized asset, there emerged this way in which the banks could essentially turn around and sell the debt to companies that would then package together very large numbers of these mortgages, and they could say, well, statistically speaking, it's only this many are going to fail, and only this many are actually going to be under collateralized or not have enough value. And
watch The Big Short.
Yeah, I mean, like The Big Short started to have these like insurance that was packaged against it, so you could have crappy loans, and then you could insure those crappy loans, and the insurance was less than the premiums you could charge for the bonds after you'd packaged the insurance with it. So you ended up in this situation where, just give me loans because I can insure it for less than the value of that I get for selling the underlying, which creates perverse incentives, as we saw. But in this case, I think that the origination layer of going and like lending out to someone, assessing them on their income and stuff like that, it's certainly going to become more automated and become more simple. But I still think there's going to need to be organizations, if they're not banks. Interestingly, banks don't actually do debt collection. They harvest that out to debt collection agencies and stuff like that. Mm-hmm. So like, banks are probably actually not necessary even in the origination in the long term. So you can take banks out of the equation, but you're still going to need physical people who have have signed to the terms of collection and repossession and all that kind of stuff. So that's still going to stay. What DeFi does is it creates liquidity in the long tail of assets. So where you have much more smaller markets than the macro housing market, let's say for JPEGs of punks or of bored apes, like that's actually quite a small market comparatively speaking to the size of even just the Californian property market in terms of value and underlying collateral. However, you now have this emerging market where a marketplace can be built for this. And you can also see this in like the long tail of tokens that are traded on Uniswap, this ability for communities to provide liquidity for these things to now be traded that previously would be considered be smaller than micro caps, right? Smaller than micro caps. And anyone who's seen anyone who has seen Wolf of Wall Street will know like how inefficient the microcap market is. Mm-hmm. It was 50% commission on selling a microcap, stuff, yeah. which is an example of a huge inefficiency, because as you get towards the long tail of asset groups, you have less willing buyers and sellers and market makers who just don't want to step into that market because they can get burnt so easily. However, what DeFi's done is it's given communities the power to go, well, actually, we think this should be liquid, so we're going to go and provide liquidity to this market via things like Uniswap. And so this liquidity has emerged. What I think is going to happen with housing, and I like once you get to the point where you can take a representation of a property, and that representation of a property, as it increases in equity, so you're paying down your mortgage, so you've gone from a 20% deposit, you're now at a 30% deposit, just 30% ownership and you're on 40% ownership. There's these concepts of home equity release schemes, like where you can go and do this very complicated process of essentially remortgaging your house with a second lien against it. I think that's going to become a lot more liquid. So instead of, let's say I have a credit card, but instead of the credit card being unsecured lending, which actually all unsecured lending is still considers your house. So let's say I have secured lending on my house, right? And I had 20% deposit down and now it's at 40% that I own, right? If I have a credit card and I'm paying 20%, 21% per annum on it, yes, my house, it's unsecured lending, but the equity that's in my house is actually still considered part of that debt. So if I get to declare bankrupt, my house will still be sold to pay down that debt. Now, the bank will get the first claim, but the credit card company will get the second claim. However, it costs me 1.8% to borrow on a mortgage, and it costs me 21% on a credit card. So what I'm doing is kind of insane when you think about the whole of a person and all of their assets. So I think what's likely to emerge is going to be this idea that your asset equity in a house can be something that can be represented and that you can essentially get a cumulative charge against via immediate spending. So my credit card now maybe actually will only have a 2% rate of interest or a 3% rate of interest because it is now the ability to create secured secondary instruments via, the efficiency of decentralized finance and the way in it which everything can be granularly represented as a liquid asset. I think that's where it will change significantly. And I think, sort of credit card lenders, which have previously been seen as quite what's the word? Sharp practices. There's a lot of sharp practices that occur in credit card lending and debt lending. Those kind of things will be less. You'll be able to do more things like collateralized lending with stuff that's more like real world collateral rather than Bitcoin or Ethereum or stuff like that. So it will not look quite the same, but it won't be completely different either. And I think you'll just see this continuous smashing together of these
more
two
efficient.
worlds. Yeah,
it'll be much more efficient.
Yeah.
And risk reduced for quite a lot of parties as well, right?
Yeah.
Especially from a credit card company. If they can see your NFT representation of your house,
right,
and how much you have available in equity and how much of that equity you spent on other things and stuff, then their risk assessment becomes a lot more granular, right? And so you could have I'm on 2%, someone else is on 3% because they're a bit more risky,
right? And an unsecured lender becomes a secured lender.
Yeah, just matter of fact.
Just matter of fact. And maybe you have some arrangement where the debt collection agency allows you just to extend the amount of debt that they can collect against. And then you don't even have to have a secondary debt collection agency. You just have the primary debt collection agency, and that debt gets added to it as a continuum. These are all possible. The thing is about unsecured debt is you always have to have some means of enforcement, and that is where it gets into the very human process of collections and stuff like that, which is why I think it's going to take a long time for this stuff to end up being on ledgers, probably 10, 15 years away realistically from getting really good unsecured or partially secured lending on top of ledgers. But it's definitely coming. And it's definitely coming.
Yeah, cool.
Thank you, everyone who asked questions. We will collate the ones we didn't answer and come back to them at a later stage. We've also got a couple from the 3rd of March and the 1st of March that we just didn't get to at all. But so we'll come back to those in the next session. But for now, thank you very much, Dan.
Thank you very much, Piers.
And I will see you next time.
You will. Bye-bye.
Bye, guys.